This is Algebra 2, Lesson 6.4, Factoring and Solving Polynomial Equations. That's what we're doing, factoring polynomial expressions, and then we're using that factor to solve polynomial equations beginning on 345 in the textbook. Factoring by grouping is a method used to factor some polynomials with pairs of terms that have a common monomial factor. Okay, then it says the pattern is RA plus RB plus SA plus SB. This looks confusing when you look at it, but this is all it is. If you look at this first set here, RA plus RB, notice they both have R in common. So if you group those two terms, you can take out R and make it say R times what to give you RA, which is A, and R times what to give you RB, which is positive B. You can do the same thing with that second pair, this one and this one. Notice they both have S in common. So you can have a positive S, and then times what gives you SA, positive S, times what gives you SA, A, and times what gives you SB, positive B. So notice that's exactly what it has here. R times A plus B plus S times A plus B. And then once you're there, then R plus S is first. And then notice this is the same right here. They're both A plus B. So it's just grouping or factoring by grouping things together. Quadratic form is very similar to what we consider the standard form of a quadratic equation, ax squared plus bx plus c. The difference in this expression, or the difference in this definition, is u represents an expression. Instead of simply being ax squared plus bx plus c, this u value is now an expression in x. So it might be something like a times x plus 2 squared, something like that. That's the difference. It'll still follow the same order. It'll still be squared, then to the first degree, then to no degree at all. Okay, factoring special factoring patterns, adding and subtracting cubes. So right here, a cubed plus b cubed. What you do with this is you take this term plus this term. That's what goes first. Then you take the first term, a, and you have it squared. Then you take both terms together, a and b, and you multiply them times each other. But when you're adding them, this is key here. This will be the opposite, minus both of them together, AB. Then finally, you take the last term, B, and it's that squared. So this is just a special factoring pattern. So let's look at that with some numbers instead. Now, x cubed plus 8. Anytime you have things that say like x cubed like this plus the number 8, you'll get used to the number 8 and 27 and 64 and 125, and it continues to go like that. Those are numbers that you count by, that when you cube them, just like we have perfect squares, like we got used to the numbers 4 and 9 and 16 and 25 and 36, those numbers, you're going to do the same thing with cubes. You'll get used to those. 8 is the same thing. This is equivalent to 2 to the third power, because 2 times itself 3 times gives you the number 8. So what this is x cubed plus 2 cubed. X cubed plus 2 cubed. And now it is the sum of 2 cubes. So the sum of 2 cubes, again, just like a second ago, is this squared, and you can see that here, that squared. Then both of these together, x times 2, but it's the opposite. Instead of plus, it's minus 2 times x, which you can see here. And then finally, it's this one squared, 2 squared, notice, is the number 4. So x squared minus 2x plus 4 is what it winds up being, times the original x plus 2. The same thing's true with the difference of two cubes. Everything's exactly the same. You don't have to memorize two things. The only thing you have to memorize is when right here, when you were adding them, it's going to be minus right there. When you're subtracting them, it's going to be plus right there. So a cubed minus b cubed is a minus b, that's first. Then the first term, a squared, plus two terms multiplied by each other, a times b, plus the last term, b squared. So an example with some numbers is 8x to the third minus 1. So let's look at that one like this first. 8x to the third minus 1. Again, 8 is the same thing as 2 cubed. So we have 2 cubed x cubed. And then negative 1 or minus 1 cubed is the same thing as 1. So minus 1 cubed. And I wrote to the second power for some reason. Cubed. So we have here is the difference of 2 cubes. So you take the first term, 2x, minus the second term, 1. That's the first thing. Times 2x squared. So it gives you 2 squared, which is 4, and x squared, which is 4. So 4x squared. Then you put both of them together. 2x times 1. And again, it's the opposite. So it'll be plus 2x. Then you square the last one. 1 and 1 gives you positive 1. So again, this gets much simpler as we do more. So don't be, I know this looks extremely confusing when you first look at it. I know it does. It's much simpler as we do a few examples. Example number 1 is factoring the sum or difference of cubes. So x minus 3, I'm sorry, x to the third minus 64. So what that is x to the third minus 4 times itself 3 times is 64. So x to the third minus 64 is the same thing as x to the third minus 4 cubed. Now you have the difference of 2 cubes. So what we're going to do is we're going to take the x minus 4 and write it just like that, x minus 4, times the first term squared, x squared, the opposite of minus now, so plus. Both terms together, 4 times x is 4x. And then the last term squared. 4 squared is positive 16. That's the difference of cubes looking like that. X squared plus 4x plus 16. For this next one, we have 54y to the fourth plus 16y. Again, just like the first bell work problem, you want to pull out whatever they have in common if they have something common. The number 2 goes into both of them, and y also goes into both of them. So you ask yourself, what do I need to multiply 2 by to get 20 to get 54 is 27? And what do I have to multiply y by to get y to the fourth, y to the third? Same thing with what do I multiply 2y by to get 16y? You multiply it by 8. So now you have 2y times 27y to the third plus 8. Again, both of those are perfect cubes. 27y is the same thing as 3 to the third y cubed, and plus 8 is plus 2 to the third. So now you have something that looks like that. It's the sum of 2 cubes. 3y to the third plus 2 to the third. And they just have it inside of a set of parentheses right there, but it's the same thing. So the first thing is 3y squared is what you're going to do. 3 squared is 9. Y squared is first. 9y, You put 3y plus 2 first. Then inside of the trinomial is what I jumped ahead to, 3y squared. It's addition, so you put minus next. And then 3 times y, or 3y times 2 is 6y, so minus 6y. And then 2 squared is plus 4. So 3y plus 2 times 9y squared minus 6y plus 4.